Hello, we are from Pervasive System Group of University of Utrecht. We are here very excited to present our work in the InSect project, where we have proposed a framework that can enable the knowledge transfers across the fingerprint datasets. What exactly the fingerprint techniques are? Well, we need two main phases to have it work. First, we establish the fingerprints database. This will include us with received signal string measurements and the corresponding locations in specific areas. The database then fetches machine learning models which will learn the correspondence between the fingerprints and associated locations. In the online phase, the trans models is used to estimate locations based on the query fingerprints. We understand that the data collection in the fingerprint techniques do require a lot of labor efforts to establish the fingerprint database, not to mention the malfunction that happen frequently during the period of working, also requiring the regular maintenance. Hence, we aim to take advantage of multiple source datasets at the same time to improve efficiencies and efficacy in the fingerprints localization with the knowledge transfer. However, straightforward transfer is nearly impractical for substantial discrepancies among those datasets. For example, different datasets were established with different infrastructures, such as the number of Wi-Fi access points and their arrangements in the buildings and the pupil densities. These things actually give rise to distinguished fingerprint distributions indicated by the bottom figure. That is also the main reasons we come to the frameworks that can enable the knowledge among different source datasets. Specifically, our framework consists of two phases to work. First, in the expert strength phase on the left-hand side, we use the GAN network, especially the generators of the circuit details, to model the representation of baseline models learned from source. The process of modeling is ensured by two type constraints: the angular similarities for correlation between the model's representation and the baseline representation. To make sure the model representations are meaningful for localizations, we apply them to localization model for the assessments, indicated by the green arrows. When the process is complex, which means the circuit details are qualified for transferring the knowledge, the expert stealing phase on the right-hand side is designed to make sure the knowledge of circuit details can be fully distilled to the baseline models in the target. To do this, we impose three extra constraints: the angular similarities for the collision guarantee, the mutual information to control throughput of the common information between the source and the target, the functional information via ellipses to control the functional properties inside the baseline models in the target compared to the details from the source. Throughout the frameworks, the knowledge transfer is expected to be conveyed to the greatest possible degree. We will indicate the effectiveness of the frameworks on the positive experimental results. First, we compare the framework with state-of-the-art transfer learning methods on the standalone models by the three benchmark datasets. For each specific model, our frameworks in the bottom usually outperform the others impressively across the three datasets, as can shown in the red boxes. Now coming to the challenging scenario. Here, the models are only trained on a piece of training data, particularly 1% and 10% in the UTI, UTS, and temperatures, but they have to be tested on the full set of testing data. It can be seen in the table. The frameworks only have a standalone model to deliver the stable performance across 3 datasets, which can be seen by the red boxes. So, to conclude, we are for the first time bringing out the frameworks that can enable the knowledge transfers among the fingerprint datasets, which creates the representation alignments among those. This actually can help to learn the transferable representations that are more resilient against the dynamics of the target datasets, hence increasing the performance in localizations. Finally, thank you for your watching.